Hey everyone, this is Rodrigo Silveira with EasyLearnTutorial.com. This is tutorial number 22 of our web programming step-by-step series. And in this tutorial, like I said last time, we'll be doing an example app to show you how to put together the fundamentals of JavaScript to create an actual application. What we're going to do in this tutorial is create a mortgage calculator. So I created an HTML file here that has a link to our mortgage, not mortgage, let me write this properly. It's a mortgage calculator. And the way it works, I went to the Wikipedia page. It describes how that works. What we're going to do is calculate the monthly payments. So the formula is right here. So the way it works is we're going to have a form. Let me just quickly create this form. If you don't know HTML too well, then that's all right. We're going to focus on the JavaScript part of it, and you can learn about HTML tags later. It won't really matter. So what this, the way the formula works, you have three fields that will ask for the interest rate, for how many months or how many years normally you're planning on paying off your loan, and then P is the loan. So the three things we're going to ask is for the loan amount. Let me see here. And we're going to have an input type text. And instead of name, all of that, we're just going to have an ID. And we're going to say in for input and call it amount. So far the form looks like this. We're not going to do any CSS and make it look pretty or anything. We'll just keep it really basic. So our form will have three things. It will have the loan amount, the interest rate, which is the APR, the annual percentage APR, percentage rate, which is just interest. And we're going to have the period, which is how long to pay off the loan. So we're going to name this ID APR, and this one the period. And I realize I'm missing a D over here. And one thing we can also do, just to add fanciness, we're going to have the down payment. And this is really easy to add. Down, let's see, down. I'll just call it down. So in this formula in Wikipedia, it just takes the interest rate, the period over here, or the amount that you borrow, and then N is the period in months. To add a down payment, we just take the total amount of the house minus our down payment, and that's how much we ended up borrowing. So instead of saying the loan amount, we're going to say the cost of the house. And cost. So then obviously the amount borrowed will be the cost of the house minus our down payment. We had to borrow the rest. And then what we're going to do is we're going to have this thing that says we're going to have just an HR like that, and then we'll say total monthly payment equals, and then instead of an input, we're going to have a span ID out monthly. So right now this span is invisible, and this is what our layout looks like so far. And what we're going to do, we could have a button that we press and it calculates. Yeah, and in fact, that's what I'm going to do just to keep it simple. I don't want to add a lot of fanciness right at once. So it's going to say button and ID equals BTN calculate payment. maybe calculate payments like that. And doesn't look pretty, but it's good enough. So right now we can click that and we can put data here and nothing really happens. So what we're going to do then is create a JavaScript block. Actually, what I'm going to do is create an external file, and I'll call this my mortgage-calc.js, and have this be an external file. So we're separating things just to simplify. And this is what I'll call the file. And so now what we're going to do is create our code all over here. The code. So let's, one thing I usually do just to make sure this file is importing properly, I'll just do an alert and say in mortgage.js. And then I'll refresh my file. And I just want to make sure that file is written in properly, which this proves that it is. So the first thing we're going to do is write a function called calculate mortgage. And this function will be called when we click the button. And what this function will do, it's going to calculate the monthly payments. So what it's going to do eventually is return monthly payments. So I need to create a variable that I'll call monthly payments, and I'll just set it to null for now. And what I'm going to do is write a comment that says the formula for, I'll just write the formula. That's good enough. And I'll go back to Wikipedia. The formula is C equals, and we're going to convert this to programming. C equals, and we have, notice we have a bunch of stuff divided by a bunch of stuff. In this case is R dot times P. When we have a bunch of expressions like that, just like in real math, if you have something like 1 plus 3 times 7 divided by 21 plus 4. We have, if you have taken math in school before, you have heard of order of operations. Order of operations. I don't know if, I guess it would be OOO. Order of operations. What it means is that multiplication takes precedence over addition. So if we have an expression like this, for example, what would happen is multiplication happens first. So it would be 7 times 3, or 3 times 7, and the result of that, 21 plus 1. And in programming, the same order applies. So an expression like this would not be 1 plus 3 equals 4 times 7. It would be 3 times 7 first, and the result would be 24. Right? 3 times 7, 21 plus 1, 24. To simplify things and make it easier to read, you can add parentheses, and parentheses will take precedence first. So in this expression, it will say 1. Before it does 1 plus something, it will go inside parentheses and will evaluate the 3 times 7. And then this will equal 21. And then later it will say 1 plus the 21. So we can add that to our code also, just to make it easy. So in this case, it was R times P. And so I'll say R times P divided by, and then some sort of parentheses. And this was 1 minus, inside the parentheses, 1 minus, and then they had their own parentheses over there. And it said something like 1 plus R, 1 plus R. And then they have this thing that is like time, or elevated to the n, which is the number of months, but it's negative. And this can be simplified. Instead of having multiplying by a negative power, we can just uh, move this to the top and divide by 1 divided by that. So we'll just use this other formula, which is P times R, which is the same thing as that, times 1 plus R. Let me redo this thing. And just so I don't have to keep going back and forth between the windows, I'll just pull up Notepad and just have it right here. So C equals P times R times 1 plus R. And y is being raised to the nth power is only this thing right here. And this whole thing is one expression inside parentheses. And in order, the way we do powers in JavaScript, let me see. So this whole thing is the power, and these two things are being multiplied. I think I got too many parentheses. Okay, so this thing is being, let's try to save this for some reason. 1 plus R is being raised to the nth power. In JavaScript, we have an object called math, and it has a function called pow, which is power. And it takes two numbers or two arguments. The first one is just whatever the number is, the base number, and then we do a comma. And the second thing is the power that we're multiplying or raising this thing by, so it would be n. So if we want to do something like 2 to the third power, we can just do math.pow 2 to the third power, like that. And that's what we're doing here is 1 plus R raised to the nth power. And I think my parentheses are good. So this paren right here matches this one. And then P times R times math.power 1 plus R plus N. And I'll collapse the parentheses now that we know what it is. And then we divide by just a huge thing inside parentheses. And it will be 1 plus R, again raised to the nth power. So we'll just do math.pow. And those are the arguments, minus 1. And that looks good to me. I guess we'll find out if this is right when we execute. So let me close this. So this is our formula. And that's what we're going to do here. So the three things we're going to take will be P, R, and N. And then I'll do another comment saying that the variable, usually they have something called param like that. This is just an annotation to tell the programmer to explain what things are in the function. And P is, I think, the interest rate. P is the amount borrowed, and this will be, it can be a float, like a floating point number. It doesn't have to be an integer, because you can borrow something like $23 and like 78 cents or something. So it's a float, and is the amount borrowed. And then the other parameter is R, and R, I'm pretty sure, is the interest rate. And it says right here, expresses a decimal, not a percentage. So we're gonna say this is the interest, not a, well, so we'll take the interest as a percentage. That's what we're gonna do. And we're gonna have another function just to help with that will convert to decimal. I guess I'll just call it percent to decimal, and we take a percent. So this function will do this conversion right here that they have. So people will give us the 6.5, so it's easy for them, and that's what R will be. And then what we're gonna do inside this function is say R equals, what we need to do is convert this percentage to a decimal, So it's a percentage. We need it to be, this formula uses R as a decimal. So we need to convert it to a decimal, and we'll just do that by calling our function percent to decimal, and we'll send R to it. And so this formula, this function simply returns same thing they have here, the number divided by 12 divided by 100. So it will be percent divided by 12 and divided by 100. And just like they have here. And then the next thing that we have is this other guy, this other parameter, which is n, which was the period, the monthly payments, or the term. And the term, they will give us in years, so it's easier. This is the term in years, and this, I'm pretty sure this needs to be in months. So the number of monthly payments, right? So if they want to pay it off in 30 years like they have here, then they're going to make 360 payments, which is 30 years, but each year has 12 months. So we're going to ask people to give it in years, so they can give it a 30 for 30 years, or 5 for 5, or like 10.5, for 5 years and 6 months. So what we're going to do is have a function called years to months, and we'll take a year, and this is pretty simple. We'll just return year times 12. And Eclipse is throwing this exceptions here. That's fine. So same thing, we're going to convert percentage to a decimal, convert years to months. And so n equals years to months, and we'll take n like that. Yeah, so that looks good so far. Now we just need to actually plug in these numbers. Since we already have the formula, this should be pretty easy. What we can do, I'll just paste that real quick, is just move this guy down here, and instead of setting it equals to null, we can just do it like that. Or to simplify it a little more, we can just return the formula, and we need a semicolon at the end like that. So p times r times math.power 1 plus r. I think this looks good. If we go to our program over here, nothing will happen, of course. There's no errors here. So what I want to do is call our function calculate mortgage, and I want to test it, and I'll just send it 111. I have no idea if this number is right, but I just wanted to make sure no exceptions are thrown. So what I want to do is see if they have an example so I can try it out. So in this example, they're trying to calculate payments. Interest rate is 6.5. Term is 30 years, and the loan, I guess they have it defined right here, for example. So the loan is $200,000, 6.5% interest rate, and 30 for the period. And the result is $1,264.14 monthly. So let's cross our fingers and do the same thing. Call the function I don't remember the order. So it's the amount borrowed first, interest rate, and terms. So the amount borrowed they had was 200,000, and then the interest rate was 6.5, and the term was 30. So in our case, we got 1.7 something something to like the negative 248. So something is not right in our code. Let's do the fun job of troubleshooting. And what I'm going to do is just do a console.log and log all of my variables to make sure they look good. And I'm pretty sure the problem is somewhere over here. We're just putting things wrong or in the wrong order. So P, R, and N. PRN, and I'll refresh the page and call my function again. So P is 200,000. That looks good. The interest rate is 0.00541, and the period, the term is 360. They had it over here where the term they say is 360, and so this guy might be wrong in our thing. So 6.5 divided by 12 divided by 100 divided by 12. So our interest rate looks good. There's a rounding difference here. Ours is like 6666 and theirs is 66667. So our numbers are right. So this part, like I thought, was right. The problem is what we're doing here. So let's check what they're doing. We can just use this formula, simplified version of that. And of course, this symbol doesn't do powers. This will actually do a different operation. So this needs to be, this whole thing is the power. Math.pow, it will take that and one extra parentheses, not a number, of course. This is not right there. So now it looks good. Yeah, I guess just the way I wrote the formula was completely off. So the formula needs to be this guy right here, which is the interest rate times the amount borrowed, and this can be like in parentheses right there. And let's see, 165, this is the interest rate, which is R, 1 plus R, and then this is the negative amount borrowed, and I don't see N anywhere in here, which probably got collapsed into, let's see, oh, right here is amount borrowed is P, where's 30? So this is negative N, that's my mistake. So perhaps this will work. So let's try this out. Come on. Refresh. And yeah, so now it's working, I think, right? 0.14. So notice we're returning like a bunch of numbers. We just want 2 decimals. And there's a function in JavaScript that will do that for us. And this is a function called toFixed, and it takes the number of decimals we want. And this is something that is part of it acts on numbers. So what we can do is say payment equals, and then we call our calculate mortgage, 200,000, 6.5, 30 years. So now PMT equals this long number. We can say PMT dot toFixed, and we just want 2 decimals. It will do the rounding, so it should say over here 0.14. And that's exactly what we wanted. Notice this is now a string. It has the quotations, the quotes around it, so that's how we can tell it's a string. And there's another function called parse float that will make things a float. So we can say pmt.toFixed to 2 decimals, and now we have a float. It's a number, and it's rounded. So this just shows that our function was right. And what we're going to do then, just to simplify this, is say var pmt equals that. And we're going to do what we just did in the console, is return. Let me just see why it's complaining. Local variable is never read. So this is saying Eclipse is smart enough to see that this variable is never used anywhere, and so it squiggles it. It says, oh, if you don't use it, then you probably shouldn't even have it here. So it's just letting us know this variable was never used, and that's because we haven't had time to use it yet. So we're going to say pmt to fixed to 2, and we want it to be returned parse float, like that. So far everything is looking good. Let's just go back here. We can close Wikipedia out. We can go back to the console and do that same thing again, and we have a float with the proper, and we can change this, right? It will give us different numbers. We don't have Wikipedia to verify that this is right, but given that this was right, we can be pretty confident that the other ones are right also. So all we need to do now is connect these things to our application. First thing, we need to connect the click event of the button. The way we do that, we'll just go to the bottom of the file here, and there's a function in JavaScript. There's several functions in JavaScript. The one I want is one that will return a reference to an HTML element and store it in a variable. So I'm going to have a variable called I'll just call it btn, I guess, for button, and the function is document.getElementById, and it takes a string, and the string is the ID property of an HTML element, which in this case is btn calculate. So once we do that, I'll just do a console log on this variable just to show you what it looks like. Here, of course, nothing happens, but I log that, and this is what it returns. And I can even access that on the console right here. This variable, if we do a type of btn, is an object, and btn has methods or functions on it. You can see all the functions and attributes it has. One of the functions it has is something called onClick, and all it is right now is null because we click it, nothing happens. What we can do is assign a function to this attribute, and we'll just have a function that says hello, just to show. And notice I wrote everything in one line, but I can have it all like that so it's easy to read. So now when I click this guy, the browser triggers this function, which before was null, so nothing happened. Now it's a function that alerts hello. So if we click that, we get hello. So what we want to do is use our reference to that button and say onClick equals, and have this equal a function. And what we're going to do is just have this equal the function. We'll just have it be just its own function for now. And one thing I don't know that I mentioned before, anytime you assign, like if you just create a function, the opening and closing brackets, they don't need a semicolon at the end. And it's the same for an if statement. You have the brackets, you don't need a semicolon. But every time you assign something, use equals, even if it's a function, then you need a semicolon at the end. So this function, what we're going to do is create the variable r, and the way we're going to do this is same thing. We're going to do a getElementById and get a reference to all of these guys here. So the first thing, we're going to get a reference to the cost, and I'll just call this guy cost. So what we're going to do is get a reference to all of the guys in the form, and then we're going to call calculate mortgage and send in the proper numbers. So eventually we're going to say the payments equals calculate. Eclipse has the shortcut where you start typing the name of a function, and then you press Control space, and it tries to predict all the possibilities. And it's not working right now, but that's fine. calculate mortgage, and we're going to send in the right order is to be the amount borrowed. So I'm going to create a variable by that name, amount borrowed, interest rate, and term, and that's what we're going to have. So before that, I need to create the variables amount. I'll just copy and paste so I don't run the risk of mistyping it. And this would be cost minus the down payment. And I'm going to have the variable down payment equals document.get element by ID. That's equals to in down. Then I need my variable interest. Again, I'm going to copy this, which will be interest can be up here. It's document.get element by ID APR. And finally, term is document get element by ID input period. Now, two things that I want to mention about this is that one, doing get element by ID will only give us a reference to the actual HTML element and not the text inside of it. Wow, and this is like undefined. That's weird. Document get element by ID. Oh, that's because, yeah, why is that? Oh, shoot, no, it's right, it's good, it was never wrong. So this function, get element by ID, doesn't return anything, it just stores this, but it returns undefined, but doesn't mean it wasn't assigned. But as you can see, what we want is the number. So let's say the house is like 250,000. If we do cost dot, it has attributes. One of them is the value, and that will return the number that's in the text, which is what we want. So what we need to do here is not just say get element by ID, but also value, like that, and like that, and like that, and like that. And what I'm going to do just before we continue is do a console log and do cost, down payment, interest, and term, just to test it. This is a good technique, is you code a little, you test a little, so you don't like spend a long time just coding a lot of lines and then you try to run it and nothing works. It's pretty hard to find out what the problem is if we do it that way. But if we just code a little bit and then test it, if something is broken, we know it's right here, so it's easier to fix. So I'm just going to put numbers like 23, 42, 108, and then 15. And what I'm going to do is if I click this guy, it's going to call this function, grab all the numbers, and then log it. And that's exactly what I want to do. So I'm going to double check that I got 23, 42, 108, 15. And so far, so good. So I'm getting the numbers correctly. And the down payment would be just a simple subtraction. I don't want to check that. Pretty sure this is correct. So now, what we're going to do, we're going to create another function just to keep things in separate functions called post payments. And this will take a payment. And what this function will do, we're going to grab a reference to this guy right here, the output monthly. And this is where we're going to display, we're going to say like xx.xx. This is like the amount. And it will be displayed over here. But right now, since we haven't calculated anything yet, this is just empty. But what we're going to do is grab a reference to this ID. And this is like the HTML element document get element by ID. What we're going to do is inside this property or this element, it has a property called inner text. If we set inner text to like some text, I'll just say hello. If we call this thing, let me copy this into the console so we can see it. If we call this function, first we're going to grab a reference to HTML, and that is our span. That's invisible right now. But if we set the inner text attribute to like hello, pay attention to what will happen over here when I click enter. It will set the text of that node to whatever we type. So what we're going to do is calculate, grab the payments inside the function over here. That's what this is. And then we're going to send this variable to the function payment, and it will display that as the inner text of our tag. So plus payment. Something like that. And that should do it. So post payments and PMT. And if all has gone right, once we refresh, the cost of the house will say 250, 123,000. Down payment, I'll just say 50,000, just so we can have the same number as Wikipedia. It was 200,000 for the amount borrowed. Interest was 6.5, and 30 years was the thing. So this should have been 140. Maybe that's wrong. Let's go back to Wikipedia, just double check. So it should be 1,264, 1,264.14. So that looks great. That's our mortgage calculator. We can change the amounts here. Let's see if we just buy a house that's 100,000 and we do a down payment of 5,000, or we do a down payment of $500, and the interest rate is 6.5, and we plan to pay it off in 10 years. Then every month we will have to pay $1,100. Notice that there's no zeros here. That's the way JavaScript does the toFixed. Doesn't force a trailing zero, and that's okay. One other thing I wanted to mention before we conclude is that we're just trusting that this numbers, the user's putting in actual numbers. Like if the user puts in, instead of a number, like the word hello, then we're going to try to perform math on a number or a string, and we're going to get a nan as a result. Or if they do something like 250,000 and 50,000, and then here if they put a percentage, it will give us not a number. If we remove that, then it works fine. And one thing we could do, I probably won't take the time to do it right now because we haven't learned other fundamentals to extend this application and make it more secure, make it so the user could put a percentage here and things would work. But what we need to do is when we get these variables, we basically need to check. So if cost, first thing we want to make sure they're borrowing, or the house is a positive number. It doesn't make sense to buy a house that's like -$2. So we want to say if house is greater than or equals to 0, we continue. So in other words, if it costs less than 0, it definitely could cost 0 if it's free. But if it's negative, what we want to do is not continue. So what we would do if the user puts in a negative number, we do alert and we say invalid cost, and then we'll return false. By doing a return false inside the click event, we just ignore the rest of the function and whatever else the button would do by default. So let me just show you how that would work. If the user puts in -5, we'll just say invalid cost, and it doesn't try to continue calculating. The other thing you will notice also, if we put nothing in there, nothing is being forced, nothing is mandatory. So what we could do is also another if statement that says if cost equals just blank, meaning if there's nothing in it, then we say alert, and we say something like please enter a cost amount, return false. So if they try to calculate without putting in a cost, it will say please enter an amount for the cost, and if we do a negative, it will say invalid cost. So in other words, the first check, it went fine. -5 is not blank, so that's good, but it is invalid over here. What you want to do is basically have if statements just somehow check all of the input that you get from the user before you continue to actually attempt to use it. You should never trust that the user is giving you proper data. That's how people get hacked a lot of times. They trust that the user will put in nothing but the proper data in the proper format, and obviously some people don't like doing that. They just want to, try to go against the rules of our programs. So that's what you want to do. There's another thing, I'm not going to explain it because there's a tutorial that explains it in depth. It's something called regular expression, and this basically what it allows you to do is to check. It's somewhat, in a very broad sense, similar to an if statement, but what it does, it checks a text pattern. So it just checks patterns against a string. So what we could do is do a regular expression in the interest rate, and we can just basically do a check and say check if interest, if this variable interest has a percentage sign. If it does, we can treat it as a percentage, and we can ignore it, remove it, so that way if the user puts a percentage sign, it won't crash the program. The application won't think it's a string, but if it says 6.5%, it will know it's 6.5 in the context of a percentage. But that's the main idea, and that is that you always check any input that you get from the user. Make sure things are valid, make sure that they make sense, and that they would not break your program. The source code for this is posted on a GitHub repository. I have a link to that if you want to check out the full source code to this sample app. So check that and play around. Post any questions or comments if you have any. Please like the video if this was helpful, and be sure to subscribe. Thank you very much.